We will now look at an interpretation of the Laplacian, which will give us an insight into Laplace's equation. So you recall that the second derivative u can be represented by this finite difference in one dimension. That finite difference uses the values of u of x and u of x plus delta x and u of x minus delta x to approximate the second derivative. We rewrote that finite difference as the average of u at two surrounding points minus u of x. So when we were looking at this for the heat equation, we saw that the Laplacian was proportional to the average of the surrounding points minus u of x. So if we want to look at this in two dimensions, you'll see that the finite difference for uxx plus uyy depends on u of xy and the 4 points that surround u of xy. And then we can rewrite this as the average of the 4 points that surround u of xy, these 4 points, minus u of xy. So our interpretation of the Laplacian is that the Laplacian of u of xy is proportional to the difference between the average of u of xy at neighboring points and u of xy. So this means that if the Laplacian of u is positive, then u of xy must be smaller than the average of its neighboring points. And the Laplacian of u is 0, then u of xy must be equal to the average of u at its neighboring points. And if Laplacian of u is negative, then u of xy must be then larger than the average of u at neighboring points. So if we say the Laplacian of u is 0, that means that u of xy for all xy must be equal to the average of its neighbors. And this has a further consequence that if u of xy always has to be equal to the average of its neighbors, then u of xy, if it solves this equation, Laplacian u equals 0, cannot have a local maximum or minimum inside the domain. So if we're looking at Laplacian of u on a rectangle, then on the inside of this rectangle, u of xy cannot have a local maximum or minimum. All maximums and minimums of u of xy have to occur on the boundary of that domain right here. And this is a special property of functions whose Laplacian is 0, that they cannot have local maximums or minimums inside of a domain, that those local maximums or minimums must occur on the boundary.